This is the same data set and the same learned model from a few slides ago. And what I'm plotting here on the right is not just the decision boundary, but it's the probability that y hat is equal to +1. So it's a probability plot. For all the points over here, the probability is approximately 0. So it's approximately 0 chances that the points there with -5 and 4 are positive, while the points over here have a probability approximately 1. So the probability of being y equals +1 is approximately 1 in the bottom right corner. So all that makes sense. And what makes most sense to me is that the region in between, right here, that white region, this is the region where the probability is approximately 0.5. And so we're kind of uncertain as to whether we're positive or negative review. And it's a region, it's a pretty wide region of uncertainty. So although the linear classifier, the straight line here, polynomials degree 1, was not a great fit to the data, the uncertainty measure makes quite a lot of sense. The points over here that were getting misclassified, I'm actually uncertain about whether they're positive or negative, and so I can feel like this classifier is doing something pretty reasonable. Now let's look at the degree 2 polynomial fit. So what happens if we use degree 2 or polynomial features or quadratic features and learn the same classifier as we learned a few slides ago, but again, plot the probability that y hat equals +1. As we saw from a few slides ago, we believe that this quadratic fit was actually a better fit to the data. So if you look at it, the uncertainty region is narrower. And to me, this makes a lot of sense. I have a better fit to the data. There's less points that I'm uncertain about. And in fact, the places where I have uncertainty are exactly the ones in the boundary region where I should have some uncertainty. The ones where I'm not sure if they're +1 or -1, they're close to the boundary. It makes a lot of sense. And so this is a really great fit, not just in terms of that decision boundary, but also in terms of the probabilities. The places where the probability is close to 0.5 are really the ones where I'm really unsure about what's going on. And it smoothly decreases, or it smoothly increases, depending on where I go to the left side or the right side of that parabola. Now let's see what happens when I use higher order features. So for example, polynomial degree 6 features or polynomial degree 20 features. We saw that those decision boundaries became really wiggly and crazy, but now if you look at the uncertainty regions, you'll see they become really, really narrower. So you gotta squint to see these because they're really, really thin, but you can see them over here in that kind of little white band. So according to this model, not only is the decision boundary this really crazy line, but the only places where I'm unsure about my prediction are these little places, thin little bands in between. So there's tiny uncertainty regions, and so I'm not overfitting and overconfident about it. The way I think about it, and I say, is that we're sure we're right, and we're surely wrong about that. So we're absolutely wrong, but we're sure we're right. And that's really bad. And so uncertainty is something that's very important in classifiers. And by looking at uncertainty, we have another interpretation of overfitting, another way the overfitting gets expressed in classification by creating this really narrow uncertainty bands. And so we want to avoid that. We want to do everything we can to avoid it.